much, very much.
Okay, ma'am.
So
Okay.
let us wait for others to join, and we shall start after 2 to 3 minutes, right?
Yeah, ma'am. Okay.
Ah, ah. We shall start off now. Let others join, and we shall not wait anymore. And this session of today is about Valmet DNA HMI nodes, which is very, very important because we'll be having our terminals on different locations in our sites. And the communication between different nodes is very important because when we get stuck in communication, our process also gets affected. So, to that extent, we need to have the very good knowledge about the nodes also. So, today's session is handled by Madam Archana. She is with us for the past 11 years and she's got a wide experience of having visited so many sites and her contribution is so much. She has visited NLC, R&M sites, NTPC Dadri site and Bhavini Kalpatam site, etc. And I think I'm having her biodata here, which I'll read out 1 minute. Archana has got 11 years of experience and she has handled the network topology for so many projects in Max DNA as well as for Valmet DNA. And notable projects are include notable projects Grondo Belarus, which is outside India project, and Bhavini Kalpakam in LCR and 4 into 1 210 megawatt New Niveli 2 into 500 megawatt, Dadri FGD, and then NO 2 into 660 megawatt. She also had visited several sites like NTPC Dadri, Bhavini Kalpakam, NLC, as I already told, for extending her commissioning support. She had visited Siemens AG, Germany, and successfully tested unified HMIs of Siemens system with MatchDNA DCS. So interfacing of Siemens to MatchDNA also, she is an expertise. She is also closely associated with several testing of development and new features of Valmet DNA and Max DNA. So this is all about her biodata. And we may hand over the session to Archana now. Archana, welcome to this session. And I request all our participants to please keep mute mode and any questions you post it in public. That is in everyone's head so that the question and answer are both got by all the participants. And kindly enter your name followed by a slash followed by a 5 4 3 2 1 any of the one digit which the highest order is 5 for the faculty followed by a slash again 5 4 3 2 1 whatever you feel like entering for coordination one more slash and the 5 4 3 2 1 digit is for the next tool. That format also I'll be posting across in our chat how to enter. So kindly be aware and just before leaving the site, please post your feedbacks, which is very valuable to us. Over to learning now. Happy learning to all the participants. Over to Archana madam. Please take over.
A very good morning to you all. Now we shall go into the presentation. I'll be sharing my screen. So we shall have a very quick overview of Valmet before getting into our presentation of notes. Valmet is a leading global developer and supplier of various sustainable technologies in various sectors like automation and services. The sectors include power generation, oil and gas, chemical, petrochemical, industrial gas, mining, marine, and various pulp and paper industries. BHL has established in-house facilities with and expertise as part of technical collaboration agreement with Valmet for the following things like the total integration and system engineering of MaxDNA and Valmet DNA systems and also interface engineering. BHL has also got expertise in manufacturing various modules of MaxDNA and Valmet DNA and also the panels. And it also can extend support for system testing, erection, and commissioning of all the systems supplied by BHEL. So, going into the architecture, before getting into the notes, we should know about the architecture of Valmet DNA. So, we shall see here the various nodes present in the Valmet DNA architecture. The Valmet DNA architecture is made up of robust redundant network which can support up to 1 gigabyte. So the backbone is made up of gigabyte network and we have all the nodes connected to this system through this robust network which is redundant. So we have the operator station nodes sitting here and the engineering station which is used for engineering of the entire system, the information management server which is nothing but our historian. This information server not only serves as historian but also as a management information server. So Valmet as a total solution package has got management information server parameters also with this information management server. And we have the routers connected to the Valmet DNA network to expose this management information server to outside office network. We have the operator interface or the alarm processor nodes. These are the operator interfaces. Here we have the alarm processor nodes. This is also Windows based station for processing the alarms and these are redundant. We have the process control servers which has got interface to the IOs and field devices. Valmet DNA also support Profibus and Foundation Field Bus. Here comes the important node, backup node, the functionality of which we are going to see in the upcoming slides. First, we'll see about the Valmet DNA architecture a bit detailed. Valmet DNA architecture is distributed. It is not server client based. So, what is distributed? When any HMI or any operator station request for any data, real-time data from any of the processors, the information is directly shared by the controller or the processor to the HMI directly. There is no intermediate server sitting between the controller and HMI routing the real-time information. So the real-time information is always obtained from the controller or the process control server to the HMI directly. So this is the distributed architecture and Valmet DNA falls under this category. We shall see in brief about the different kinds of nodes existing in Valmet DNA and we can get into the details. First is our operator station. The terminology of the node is DNA operate. The function is operator interface. You all may be familiar with this. And this is always a workstation grade machine. And what is the software running in it is Windows based node And the software loaded is DNA operates server and client. Next comes the alarm server node. This is sole purpose is alarm handling. This is also a workstation based Windows based node. And the software loaded is alarm processor software. Next is our backup node, a very important node. This backup node comprises of all the compiled application packages. We'll see what is an application package a bit later, and it also contains all the system software or the Linux packages required for the process controllers to boot and perform their operation. It also stores the runtime parameters at frequent intervals. So all this functionality is combined into a node called backup server node. This is also a workstation based node, and the operating system is Windows based operating system. Software loaded is backup node software. Next is our engineering server. Engineering server. The main functionality of engineering server is having the engineering tools with which we can engineer the entire system. And it is having the main database called the repository. The repository is the main interface between all the databases, all the functions what we defined, all the pictures whatever we defined for that particular plant, everything reside in this repository. So this is a server based hardware, and always we give a server based hardware, and Windows Server operating system is loaded in this. And the software loaded is engineering server and client. Engineering client. Engineering client, we load only the engineering tools. There is no repository residing in engineering client. Any engineering client whichever wants to access the repository has to contact the engineering server, and the same database only will be accessed. Throughout the plant, the database is unique. There are no multiple databases existing. And this can be a workstation or laptop. For our convenience of commissioning, we can load the client in a laptop station. And this is also a Windows based node. And here we will load only the client software, engineering client software. Information management server. As I told, this is nothing but our historian. It is used for our trend history, and not only the trend, also the alarm history. And not only trend and alarm history, it is very important for it is
I
very important for
just a minute, madam. Madam Archana, madam, just a minute. I think our participants have logged in through their VC hall also on their mobile. So lot of background noise is there. That interference is too much, voice interference, noise interference is too much. So kindly be seated outside the VC hall if you are attending through your mobiles, or you need not come into the mobile and you can watch on your VC. So there are these options you may please follow. Kindly do not create noise because all other participants will get disturbed out of this, and lot of echo is getting generated. Please cooperate, keep in mute mode, and do not get into the tool in your VC room, please. Thank you. Archana madam, please continue.
yeah. So I was talking about this information management server. Information management server, the sole purpose is for historization of the data for trend and alarms. All the alarms which we see or collected by our alarm server are pushed into the information management server. This not only serves the trend and alarm history purpose, but also it serves as a main tool for reporting and analyzing. Not only within the control room, but this can be extended as part of management information server to the external world or to the office. So this is always a server-based hardware loaded with Windows Server and information server tools. Next comes our process controller, which is nothing but our ACN. There are two types of ACNs right now we have supplied. CS, earlier we were supplying this ACN CS, but right now we have shifted to this MR, modular rack type controllers. So this is the latest one available. So this process controller you all may be knowing, it interfaces with all the IOs and field buses and also with the external world through Modbus. OPC is always through a Windows based node, but all the Modbus interfaces are done through our process controllers. And to say an important note about this process controller, there are no softwares existing in the process controller. Everything is loaded from the backup controller when the process controller boots itself. We shall see this in detail, step by step in pictures I have put. So now we'll start with our engineering server node. The main features are listed down. Then we can go into the files. So the engineering node has got a very powerful tool called the DNA Explorer. This DNA Explorer is a single interface to design all our field devices, our panel hardware, our pictures, and our foundation field bus. So this is a single window to open and design all these things. And it can, by a single double click, you can go to the functionality and see like whatever is designed. All these, whatever we design using this tool, DNA Explorer, is stored in a single database called Auto Info database. Inside this Auto Info database, we can have several workspaces, but repository is the one where the real database resides. This is your repository is having all your final database, and only this database can be downloaded to all your ACNs, activity control nodes, or your operator stations, or to BU. So only whatever existing in repository can be used for downloading. So this tool you all may be familiar with. The second important tool of our engineering server is the picture editor. So in picture editor, what you see is what you get. It has got extensive library of various three-dimensional devices, tanks, pipelines, and other process components. So this is also part of our engineering toolset. These are all license-based applications. So all these licenses are already will be loaded in the engineering server before dispatch. So without license, we cannot open the DNA Explorer or the picture designer. Even the version of the picture designer is very important, which is also mentioned in our license file. So we have seen two important tools of our engineering server. Next, we'll see how the database is downloaded to the working environment. So this is our DNA Explorer tool, which we have seen. So whenever anybody gives download, it first goes to the database is in the repository, and when you give a download in the engineering server, all the databases are pushed into the backup server node, and a copy of the same also goes. First it goes to our backup node, and a copy of the same also goes to the respective nodes. Here you can see the various packages. DB, these are all databases. These are all called packages. Packages are nothing but a group of applications specific to a particular node. If you see A1, this is the alarm package specific to only alarm server. So wherever alarm server exists, it goes there only. And A1 and A1CR, A1 A1CR is the control package which goes to all the alarm server and operate servers. A1O is the operate module which basically goes to your operator stations, and AH01 is the history module. L stands for your link, So this link goes to only the link processor, and the P stands for your process. So the application packages specific to your processors go to only those specific processors. So we are defining in our backup node where each of this package should be destined to. So only the node which has the necessity to receive the package will receive the package. All unnecessary packages will be pushed to other nodes. So this is how the download is happening. Now we'll see about our backup server node. As we told, this backup server stores both the application packages. These are the application packages. So all the application packages are stored in our backup node, and also the real-time parameters. Real-time parameters from our ACNs are at frequent intervals stored in our backup node. In our backup nodes history disk storage. So the backup server not only contains the configuration application packages, but configuration of other nodes also. For example, when a process controller hardware failed, when any ACN failed, you need not worry, only replace the ACN hardware. All the packages and the required softwares to boot the ACN are loaded from your backup node along with the most recent real-time parameters. Whenever the last time real-time parameters are loaded in your backup server, all those will be loaded by your ACN. So it will have the latest information available in it. And if you see the relation between backup server node and the Valmet DNA nodes, the other nodes which are Windows based, whenever a power failure or hardware failure, whenever a power failure happen, the Valmet Windows based node boot itself automatically because the Windows system software is available in the node itself. Since it is a Windows based node, in case of ACN and other ACN nodes, it has to take the system Linux software from the backup node. But in case of other Windows nodes, they boot up automatically and take only the process related databases from the backup nodes. So when even in case of power outage, there is no worries. Automatically they will boot up and become operational, completely operational on their own. So this is how BU operation occurs. From engineering server, we will download the software to BU node. So BU will have all the application packages and node configurations. Node configurations means configuration of your um, all the ACNs. Every ACN has got its own system file and hardware file. All those files are related to the configuration of ACNs, like what all field buses are existing in ACN and what is its IP address, what all operation it has to perform. All that is residing in the BU. So when any ACN, new ACN comes up in the network, it is totally blank. Only the token ID is loaded into this ACN. So when any ACN you are trying to boot, it will look for a boot IP. Because nothing is loaded in it, it will look for a boot IP. And it will search in the network and BU finds it. Once BU finds it, it responds saying that I am the DHCP server and my address is this one, 172.30.0.1. Once it responds that my address is this one, now our ACN will know that there is a server existing in the network with this address and I have to take all my files from this server only. So next what it does, it asks for give me an IP. So the IP of boot server is this one, and ACN now which is blank, totally having nothing, will ask for a boot time IP. So I will boot with this IP, and once it is booted, it will totally forget about this IP. So once it got the boot IP, now it slowly asks for what all the files needed. So all these are Linux files for booting the ACN. So one by one, all the files are pushed from BU to ACN. So in at site, if any case this ACN is not booting, we need to connect a monitor and see. I think in the site ACN CS will be available. So if ACN is not booting at struck up at any point, if we connect a monitor, we will be able to see the booting is happening at which stage, whether it has reached this stage or still it is in this point, IP point. We will be able to see and we will be able to trace the problem. If ACN is getting only IP and not all these files, required files from BU, then we need to check the network. It may not be having the proper network connection, or these files are not existing in BU properly. Sometimes if the backup node has failed and you are reconfiguring, it is our responsibility to copy all the required files from backup node, old backup node, and to maintain a proper backup. If any of these files are missing, ACN will not be able to boot. And this we can understand by connecting a monitor to the ACN. So these are the files which gets loaded from backup node to our ACN. So after this, ACN is completely loaded and it becomes operational on its own. So now we come to, we have seen the engineering node and backup node. Now we can see about the DNA operate. We can see about all these nodes in brief, and I will explain about the files required for each node. I have a demo server connected here. Through that I can explain. So now we are going into our third node, which is our DNA operate. And you may be all familiar with this. There is a control panel, picture window where we see our picture, and this yellow border is the replay mode, which is playing taking data from history and playing in replay mode at a older time. So our DNA operate has got various tools which are very quickly adaptive. Like we can arrange the picture windows, we can resize them, or we can zoom or pan any window. See, any desktop, if you create like this, you can add this total desktop layout itself to the favorites. So whenever you log in, whenever a new operator comes and logins, he can directly open this layout because he may be monitoring only a particular function. So under this favorites, he can drag and drop this layout itself. He can save this layout itself. So all these features are available just by navigation, drag and drop. So there are several operation tools which you all may be familiar also. They for used for a sequence of events and replay. We have the replay time machine where you can go to old date for seeing the performance in old time or the process in old time. For that, all the signals of the particular picture which you want to see in replay mode should be available in history. That is very important. If everything is available, that particular picture you can open and scroll back to an older date and time and see like what is happening. This is useful for your trip analysis also. And this, there is an important thing called diary entry, where in control panel we will have a DNA diary. This you can click and any operator can log his diary entries, like any trip related or any changes he has done or any maintenance happened. For the next shift personnel to know about it, he can make a record note in it called DNA diary. This also will be stored in our historian station. And at any point they can just click this open and see. This is our new interlocking windows. Earlier in this is available from collection 16, collection 17 onwards. Earlier collection we would have given the old interlocking, which is web based. When you right click, you will get a link and web based interlocking will open. But this is a new feature available in Valmet latest collection, where the pictures are directly linked to interlocking windows. You can see the indications in this operate itself. There are few questions. I will answer them. I have noted down. So when you right click on any of the picture, you can go to the interlockings page, and you can see the indications also. So this is the DNA tracer trend and analysis tool. This also you may be familiar, where you can drag and drop and make this trend page. There are several options available here. You can add a hairline, you can show the legend values, and you can save it also. And you can copy the data also in and you can paste it in an Excel or Notepad for analysis. So these are the reporting features available as part of our information server. Information server has got, if you go to the My Community is our DNA portal for all the management information for all the, please mute it. So through My Community, we can access all the management information related reports and other features. Even we can use this tool for analysis of alarms. Like there are how many standing alarms, and over a particular duration, how many alarms are there, and what is the response time. All those analysis can be done through this. This is a very extensive uh, tool. I am getting questions about BU failure. I will brief it while I am explaining the files. So this is our alarm list facility, where we have the time at which all the alarms to be particularly noted appear at millisecond resolution. Even our cards are equipped with scanning at millisecond resolution for all the signals. So all the alarms, as you know already, are stamped at millisecond resolution with priority whatever is defined by us. And from this alarm page, we can directly right click and open the particular picture or the loop window. So it is all integrated. Even we can go to the DNA diary, and it has got very many options like sorting, filtering, all those things. As we saw earlier, My Community page is available in all collections. In collection 14, 16, 17, it is integrated part of this information server. So it is available in all. It is available in all the versions. So when you create a trend page, at one click we can navigate to this any signal. Just right click and one click DNA trend. You can navigate to this page. It will directly get connected to the information server and populate all the signals here. And for deeper analysis, you can even see the red dot here. It will show like when the event has occurred and all the details about that event. And if you have made any diary entry for that signal, that also you will be able to see through the My Community. So My Community is a very powerful tool where you can integrate all the things and see anything related to any event can be available. Only thing, the proper entries to be made, and you can configure the reports and save them for any time analysis. And we have a specific session for info also, where everything in detail will be explained. So this is again features of My Community. I am just explaining in overview. We have a particular session for this where in detail we can see all these things. So there are several reports available under this. You can configure a number of reports, and we can see the trends also, and we can see many graphs These are all for management information. We can use production analysis, use these things for production analysis, and you can export them to PDF or Excel or any custom format and provide it to management. So this is again the same thing what I explained. So we'll see about Walmart DNA communication and get into the files configuration. So Walmart DNA communication, this is called name-based communication. Name-based is nothing but every signal name is unique here. So any ACN or any operator station wants to get real-time value of a particular tag. For example, this LIC-100 is a signal name and it wants to get information. What it does, it puts the query into the network. I need the value for LIC-100. It is called multicast query. That is, it is announced to the entire system. All the ACNs will get that query, but only the ACN which has got the answer or which is having the value will respond. This is called unicast. So there are multicast and unicast queries involved in this communication, and it is name based. Only through tag names it communicates. That's why the tag name has to be unique throughout the system. So how the communication at what interval and how it happens is, so between any PCS, in every process control server or ACN, all the logics are executed in different cycles based on how we configure. So between PCS and BPCS, the data exchange happens based on the cycle time we define. So for a particular cycle time, the logic gets executed and the output is shared with other PCS if our logic says so. And from from PCS to operator also at cyclic time it happens. But from operator to PCS, that is command. Command happens whenever we issue only. There are no frequent updates from operator station to PCS. There are no cyclic updates. Whenever we issue command, only that time it gets updated. But whenever you open a page in operator station, all the signals are obtained from PCS. So this is all subscription based. Whenever we want, we get the data. So this you all may be knowing what is a control task and what is control cycle. There are several control tasks defined in every ACN. So this control tasks are performed by our ACNs at particular control cycle. So I have to complete my control task within this designated time which I am defining in my logic. So within this 10 millisecond, it has to complete all the things like collection of IO values, then performing the function, executing the function blocks, then pushing the output to another processor if required. So it executes all the function blocks, and finally, when the task is finished, all the outputs are returned to your IO bus and to the PCS nodes. So IO field bus also you might be knowing. One field bus can accommodate only 16 IO groups, and each IO group should have a IO bus controller which scans the IOs cyclically and shares the information with the process control server. So this multicast and unicast updates within the Walmart nodes. How it happens? Whenever a DNA use server is nothing but operator server. Any operator station queries a particular signal. It sends to the switch. Through switch, it is spread to who has got this LIC-100 tag. It is spread to all the nodes. This update query is sent to all the ACNs in our system. Later, only the ACN which has got the answer will respond. So this is called unicast updates. This is how the communication happens in background between operate stations or Windows-based nodes and our ACN controllers. So here we have the operate server, and these are all clients. So this is operate server and operate client concept. When the operate server gets the information, it will share with all the clients also. So network, we generally follow two network topologies. One is turbo ring and other one is RSTP solution. Turbo ring is formed when the network is small and slightly distributed. But we go for RSTP wherever the network is bigger, like mostly for 600 megawatts and bigger networks where several nodes are there and it is very highly distributed. We go for this RSTP solution. But the ring solution advantage is the recovery time is very fast, less than 300 millisecond. But wherever you have a very high distributed architecture, like where you involve several fiber networks coming into picture, it is advisable to go for RSTP topology because troubleshooting also will be easy. Somebody has asked to explain this once again. I will just quickly go through once. So whenever a DNA server is nothing but an operator station wants to get any real-time data, it will send a query in the network. Network is shown as a switch here. Network is formed of switches. So whenever this server wants a data or a signal value to be shown in its picture, it will send a query. This query is called multicast update query. What it queries is who has got this signal information I want to show in my picture. So this query is sent to all the ACNs in the network. This is called multicast update query. But all the ACNs will not respond back because the communication is name based. Only the ACN which is having this particular signal will respond back to this operate server. That is called unicast. Uni means one to one. It is giving one to one communication. At the beginning, it will start with multi communication. Later, it will cut down to unicast. Only the ACN which has the thing responds. And later, I don't know if you are using in your site this DNA use server and client concept because nowadays we are giving as many as servers required only. So every operator station will act as a server separately. There may not be clients existing. I will explain with license file what is server and client in the coming up slides. Hope this is clear now. This is a very important concept which we need to understand before designing any HMI network. Not only HMI, any system, any Valma DNA system. This is called DNA IP addressing. DNA IP addressing. In Valma DNA, the architecture is subsystem based. We have several subsystems. And these subsystems, every subsystem will contain maximum of 50 nodes. You can see here 1 to 50. 1 to 50 nodes are available. So first, when we start designing any network, we will see how many nodes are available in that particular system. This includes your SG system, TG system, POP system, and any other offsite packages. This also includes your not only your ACNs but also your HMI nodes. So altogether put, you will calculate how many nodes are there. For example, I have some 200 or 250 nodes in my system. Then I have to split it into 50-50. So what we are doing, we will keep HMI nodes under one subsystem, which is called subsystem A. And then I will keep my SG and TG nodes under another subsystem called B. And then BOP nodes under another subsystem called C. Likewise, it will go on. And for every subsystem, that is for every 50 nodes, you need a backup server. So we will be designing the number of backup servers based on this concept. So for example, I have this subsystem which is called A. For particular unit, if you see, there will be 3-4 subsystems A, B, C, D, like that. And all these subsystems are available under one control room called A1, B1, C1, like that. So unit 1 we call control room A1, unit 2 B1, unit 2 C1, like that. But within a particular control room, if you go inside and see, there may be several subsystems A, B, C, D, like that. So the backup control node, the nomenclature we know A, B. B is for backup. So this is the backup node for this particular subsystem. This serves as the backup node. So these are all our ACNs, AP01. Some 2 minutes. Sorry for the trouble. There was some issue. I just connected back. Hope I'm audible now. Yeah, okay. Now I was explaining this subsystem. So we have this backup node for subsystem, and we have the process control nodes and other nodes also. So every process control node defined here and the operator station or alarm station, they will be taking their inputs only from this backup node. So for other ACNs, other backup node of that particular subsystem will serve. So we have a unique ID called hardware address and token address existing in every subsystem. These are all your token, unique token like 1 to 50, and this hardware address is hexa based 2141. So all these are all numbers are already fixed and predefined. And IP we are defining. It always the private network here is 192.168.0. So for subsystem A, it is .0. For B, it is 0.1. For C, it is 2. Likewise, it goes on. So this is an example of a large network. As I told, if you see here, this is unit 1. Under unit 1, you may notice here there is a subsystem A, subsystem B, and subsystem C. And every subsystem has got one backup node, one backup node, one backup node. And these three subsystems are hooked up together to form unit 1. And these together form control room A1. Like that, unit 2 also is having subsystem D, E, and F, and control room B. Similarly, unit 3 will have GHI. In case of several units, multiple units, it will get extended like this. Unit 4, and we will have common system like AHP, CHP. All those will have different subsystems. Nowhere the subsystem will be common. It is all different throughout the plant. So now if you see, these subsystems are connected to the switches. These are this is an example of RSTP architecture, since it is a very big network spread across the entire plant. It has got several units. So we are going for RSTP in this case. So we have used these switches for connecting all the ACNs and the HMI nodes. Similarly, in this unit also, all the ACNs and HMI nodes are connected here also. And finally, this is a layer 3 switch where all the switches are hooked up here. You might have used some 20-30 switches here. Everything is hooked up here. Similarly, hooked up here, and taken further to a very big architecture for exposing outside. This is the layer 3 switch. We use this Cisco 3750 switches. Here all are hooked up. All the units are hooked up, and it is exposed to, in our info server and all will be exposed to the external world through this router, where the management information my community page can be accessed from this office network through the web browser. So through web browser they can open from office through the connection of our info server through this router. So they can type the IP of this info server, which is sitting in our DMZ zone. DMZ is our demilitarized zone, which is for safety purpose. We provide all the info servers sit in this zone, or we will connect the third network, which is away from our DNA network, to this router, so that only management information server page can be exposed to this office network. Or there is an Excel utility which can be loaded here, and through which they can extract information from this server for their management information. So this is an architecture of a very big network. Okay, now I have given overview of all the nodes and networks and the system architecture. Now we shall see about the files, like how we configure the files for every node, each and every node. Before that, there were some questions related to BU failure. See, BU, I'll be sharing this. So this is a demo server existing in our network. I have taken this online. So whenever we install Valmet, it goes into this D drive. So D drive, we have a folder called DNA, which is our dynamic network of applications. This DNA is comprehensive folder which contains all the subfolders. So inside DNA, if you see, the three important folders are CA, EA, IA, and OA. OA is your operations activity, specific to your operator station. So if you log into your operator station and go into the DNA folder and see, this OA will be existing. No matter whether other folders exist or not, if the functionality is available, the other folders will exist. Otherwise, it need not be there also, but OA will be definitely existing. If you go and see in your engineering station or engineering server, which is a server grade machine, EA will be available and data will be available. This is your engineering activity. So these two folders will be available and important in your engineering station. If you are going and seeing in your information server, IA will be there, which is your informations activity. CA is your control activity, and this is very specific to your backup node and your third party interfaces, your diagnostics, all those activities exist under this node. In case of BU failure, you must be keeping backup of this DNA folder of all the workstations. That is very much advisable. So in case any hardware failure occur, just copy this DNA folder. This is not applicable to engineering server. Engineering server also you keep a backup of your DNA folder, but recovering that is slightly different mechanism. But in case of other nodes, you take the entire DNA folder and keep it in your hard drive or location which is specified for that. So in case of any node failure, you can put back this DNA folder in that particular new node so that it functions as good as old system. So in case of BU failure, same thing you are going to do. All the files related to BU are existing under your CA BU folder. See, you can see the databases here, AP01DB, AP02DB, like that all your databases are existing. Your license file is existing. DNA underscore law is your license file. Hope you all will be knowing about this license file. Any node can start only if license exists inside the backup node. So this is the license file. Here you can see EA. EA is all your engineering license. Unless the license exists for your tools, editor, all this, no, you will not be able to open and engineering tools also. As I told, there is a special license. This use editor is your picture designer. There is a special license. So for all these things, you should have license existing to create your database. And this is your operations activity. That is your operator station license, OA. And these are all for your processes, AP, BP and all. So these licenses should be existing for these nodes to even boot and come up. If license is not existing, they will not be able to boot and come up also. Performing function is secondary. First, to boot and come, show its existence in the network is important. For that, license is required. Next, the performance we have to see what all licenses are existing. So this is tagged with your hardware ID. And any change in this file will corrupt the entire license file and no node will work. So we cannot manually edit anything in this file. This is always hooked up with your PC's hardware ID, which is always your engineering server's hardware ID. So all this information exists in your backup node. So once you have the backup of this BU folder, you can copy it into the same location into your spare PC and set up your backup node. Then set up your IP and put it in the network. That's it. Your backup node is ready. So as I was explaining about the main folders, EA, IA, CA, OA, data is also an important folder where your repository exists. Under EA, all your databases are there. This is very important. So we will start with configuration of a simple operator node. Operator node, for any configuration, directly go into the operations activity. Enter there. Here under operations, we have two things. One is your alarm server and other one is your use. Use is nothing but your DNA operator station. ALP is nothing but your alarm processor. So in two of your stations, alarm processor and your operator node, you have to enter into your OA only for any configuration changes or any troubleshooting. If we go into use, CPU, there are two files called CD manager and QEMGR. So these are the two important files. First one is cdmgr.cpu. So this is the file which defines your operator server. Your operator server name is A101. It is defined here A1, O1. And the backup node is defined here AB01. So for every node, we told that a backup node is required. So that definition also should be mentioned here. And all the applications which this operate server should load also are defined here. So this is the main definition in configuring an operator node. So after configuring this, we will be configuring the operator client. So in any operator station, there will be two slots running. One is for operate server and other is for operate client. So the file related to operate client is qmgr.conf. So this is for your operator client. We should define here which is the operate server for this client. So A1, O1 is the operate server. This operate server and client coexist in same station. For example, if you are talking about A1, O1, slot 3 will be your operate server, slot 4 will be your operate client. So various options are defined here about the windows, loop window options. All those are alarm related options. Various options are defined here. Usually we will use the default options. If any changes required, we'll go ahead and make changes here. So for operators station, we have seen two files, cdmgr.conf and qemgr.conf. These are the two important files which are to be checked in case of any issue with operator station, or when you are configuring a new operator station, you have to look into these two files only. So this is our slot controller. This you all may be familiar with. This slot controller will be existing in all the Walmart DNA nodes, even in your ACNs. Not only in Windows based nodes, even your ACN will have this slot controller. Slot controller is nothing but the list of applications running in a particular PC. Only Walmart DNA applications. For example, in this particular machine, this is my demo server. Here I am running all my applications. See, backup node is running AB01 and your processor is running AP01. There are several processors AP01, BP01, and you have your operator station here A1, O1. As I told, the slot numbers are already designated. We generally don't change the slot numbers. Always operator station will be running in slot number 3 and slot number 4. 3 is your CDMGR and 4 is your QEMGR. These two files only we have configured now. So these two slots should be running successfully to work on your operator station. For this slot to start, that is A101 to start, it looks for a license from your BU. I opened the DNA log file and showed you where A101 is listed. Only if that is available, this slot will start. So if this slot is not starting, you need to check the permission also. So if you give a some other name A1 O5 O6 like that and all, it may not start because that license may not be available in your license file. So the name existing in your license file and your operator station name should both match. So this is about your operator station file configuration. Next we can see about our backup node. So as I told, 3 and 4 are always reserved for our operator station. Backup node we will be configuring in slot number 15 or slot number 1. Based on site requirements, we will be configuring either in slot number 15 or in slot number 1. So before getting into other slots, this is a very important slot, slot number 16. Without slot number 16, no communication can happen in Walmart DNA. This is our network communication unit. This slot should be running in all the stations. Being it a Windows node or a ACN node, it should be running in all the stations. This is our slot number 16. So here if you can see, all the slots are already populated. But where are we defining them? These are defined in a file called system file. This system file in every station will be existing under DNA folder. See .sys file. Under DNA, we will be having a .sys file. This sys file will define how many slots or how many programs are running in this particular PC. This is a template of a system file where we will be defining the subsystem number A, B or C or D. That subsystem which I explained earlier will be written here, and the hardware token address which we saw in the presentation, that also will be updated here, and the backup node name will be updated here. Then comes the net slot configurations. So first is our network communication unit. This is a very important slot. Even you don't configure any other slot, this slot should be existing for general communication, Valmet communication among your stations, workstations and your ACN. Even in ACN, this slot will be running. If the slot is stopped or not running, Valnet communication will never happen. So if you are not able to communicate with any ACN or something, you just check whether this slot is running. This slot will run only when the IP configurations are proper. You can check in your network adapter whether your IP is configured properly in Windows Node. Once it is done, this slot will run properly. So once this slot is configured, if imagine this as my operator station, next I will configure only these two slots, 3 and 4. I will not put any other slot in my operator station. So 3 I will put my CDMGR and 4 is my QMGR. You need not worry about these lines and all. These are all existing in templates. We have to just copy paste the template and just change the name here. A101 or A102 or whatever station you are configuring, that name has to be given. That's all. So now your operator station is ready when these files are put. Now you can plug in network and work. In case you are configuring, in case of your operator system failure, you are changing to a new operator station. In that case, just copy the DNA folder of operator station into this. That's all. You can just plug into the network IP address of old station you have to put, and it is now operational. So operator station we have seen, and the system file which is existing in under DNA folder of all the stations, this we have seen about. Now we can see about BU configuration. As I told, for BU we have to go into CA, control activity folder. Inside CA, BU folder. See, everywhere the templates exist. Whatever file configuration we need, we will take from template only. There are nothing extra we have to do. Open the template, use the file and change wherever necessary. So in case of PU configuration, it is as simple as like if you are replacing the PC, the old backup files you can put into it and make it functional. In case you are troubleshooting something, some download is not happening, you are going to troubleshoot, what you will be doing? You have to, in every backup node, there will be a GRP file and SYS file, system file, related to the backup node. With the backup node name, it will exist. See, the backup node running here is AB01. So we have AB01 GRP file and AB01 sys file. What is defined in this system file? This system file will have the list of all the controllers and Windows nodes connected to it. We have seen something called hardware ID. In every subsystem, every node is having hardware ID. That ID will be defined here. Without this definition, none of the node will boot. Any node requesting for boot any ACN, for example, if you are powering on the AP01 ACN, and if this line is commented, that ACN will not be able to boot. It will take a boot IP, it will load the Linux file. Only after BU checking this, BU will check in its system file whether this fellow AP01 is listed under my control or not. If it is not listed, it will not respond back and it will not give even a single file. In that case also your ACN will not boot. So if any ACN is not booting, you need to check this. First, in every ACN there will be a card, memory card. That card will have the hardware ID and token address. So that hardware ID, if it is matching here, ACN BU will see, okay, this is the hardware ID and the name is AP01. So all the AP01 related files I should share. Then only it will share. If it is not listed here, none of the files will be shared. So this is the system file of backup node where all the nodes are listed here. Another important file is GRP file. This is related to your download. When you are giving a download command, this file only says where my database should go. Here you are defining if you are downloading package AP01, you are telling that it should go to ACN AP01. If you are downloading package AP02, it will not go to other package like AP51. This is my test setup. So all the packages are going to same ACN. But at your site, it will be like this. AP02 will go to AP03. AP02 package will go to AP02 controller only. So this AP01 controller will not read this package and will not get downloaded to this controller also. Similarly, AP4 will go to 4. So at site, it will be like this. Since it is a demo server, all I have mapped it here. So all the download related information will be defined in this GRP file. So there are two important files of BU, AB01 sys and AB01 GRP. At site, in fact, you will be having like this. A1 will go to A1 underscore main and A1 underscore reserve. Because you will be having redundant controllers. In my case, it is all virtual. There is no real-time environment. So it is all defined like this. But in real time, you will have the main and reserve, both the controllers defined here. So all your package will get downloaded to both main and reserve controllers. For ACN booting, another important thing to be noted is your project ID. This also will exist under CABU only. There will be a unique project ID for every project. For example, NALCO, if you see, NALCO, if this file will be existing in all your ACNs also and in all your PCs also. So this has to match. You will see this also. If this is matching only, so it will keep check on both. It will check your project ID also. It will check your hardware ID also. It will check in BU system file whether I am authorized to respond to that ACN or not. So it will check the system file. So these many checks are involved. So any other ACN cannot boot from this particular BU. After confirming to all these requirements only, that give the files for ACN to boot. So this file also will be existing in your backup node. And here you can give like 2, 3 also. So any ACN with Vijayawada ID also will boot. Any ACN with this NALCO ID also will boot. So this ID is important and unique to the project. So these are the DB files which our ACN will be loading. So all the logics which you are downloading through your uh, all the logics which you are downloading through your DNA Explorer comes and sit here first. And a copy of this go to the particular ACN also. This GRP file and system file is specific to your backup node. This AB01 and AB01 sys and GRP file, the name is like this only. It starts with backup node AB01, AB01, GRP sys. This is specific to your backup node only and exists in your backup server only. There are other files called system file .sys. This .sys file only exists in all the stations. The GRP and SYS file of BU, which starts with the BU name, is unique to your backup node only. It will not exist in any other server. It is specific to backup node only. And this .sys file exists in all the nodes, all the workstation, ACN, all the nodes. In case of workstation, there is a location called DNA and you are putting your system file. But what we do in case of our controllers? In case of our controllers, as we discussed earlier, everything is done by our backup node only. So all the files are put in backup node. So my ACN will have three files: system file, hardware file and CPU files. So all these files are put here. For example, CP01 CPU file is put here. CP01's hardware and system file also will be put here. So when it boots, it will collect the file from backup node and it will boot. So this is related to your backup node. Any doubts are there till this?
Any questions from participants, please?
I have a question like how are we doing ACN addressing? ACN addressing, as I showed my PPT earlier, ACN addressing is also done in this fashion. See, the hardware address is defined here. It is all predefined. Only you have to place your ACNs here. If I want, I can push my ACN here, AP01, AP02. AP01 main, if I want, I will put here. And AP01 reserve, I will put here. So this becomes hardware and token address of my ACN, AP01 main and reserve. This is how we do addressing of ACNs also. So all my SG ACNs I'll bring and populate here one by one, AP01, AP02 like that. And corresponding token and hardware address and IP address I'll take. This is the addressing of my ACNs. Even for PC, I will do the same thing. I'll put the PC name against this and take the hardware address, token and IP address. So like this, this is example of subsystem A. Like this, Excel sheets exist for, there is a template available for this subsystem addressing. Subsystem A, B, C, D till S we have, and it is all predefined. You just populate the node names here and use the token, hardware address and IP address there. So it is all fixed. Whenever we talk about a particular token, if you tell token number 6, always the hardware address is C1 and always the IP address is 192.168.0.6. This 6 is nothing but your token number. So this is all fixed and predefined. We have a defined Excel sheet available for this. We start the project with that only. Even for your I have a question. Can we have tracer and history for digital inputs? Yes, we can have. Only the digital signal you have to add it to your information server. In the information server class, we will see in extensively like how to add a particular signal to the information server so that you can see the data availability in trend or report. It is available for digital and binary drive signals for everything. So in a very easy way, how to add the signal uh, to the information server through Excel sheet that we can show in information server class in a very detailed manner. Oh, there is another question like can we clone hard disk to have same data to meet emergency? Uh, can you please elaborate this question? See, there is a facility available called RAID. Raided hard disk we already supply. In case of backup node, we give RAID 1. So these are all hot redundant hard disks. So if one disk fail, the other disk will automatically have all the information and it works. In case of engineering server and information server, we supply RAID 5 hard disk, which is have still more good redundancy feature available in it. So the information is striped and stored across three hard disks, three rated hard disks. So if any hard disk fail, you can take that online and put back it. So the hard disk itself will build its own database without any outage of information server. We can take out that failed hard disk and put a good hard disk where you will be maintaining the spare of that hard disk. Or if you have a spare server, remove the hard disk from that server and put it here. So there will not be any problem in case of raided hard disk. You can do this online itself. There is no need of shutdown of your information server, backup node, or your engineering server. Only thing is you should have a RAID hard disk spare available. If spare is available, nothing to worry. Without any shutdown or outage, we can rebuild the hard disk. Um, Somebody has asked like if group file exists only in BU, then engineering server defines particular address or node. Uh, this group file existing in BU is for BU's understanding because the download first happens whenever we download engineering server. This package first goes to BU. So it is for BU's understanding where the copy has to be sent. So the group file will exist only in the backup node and not in the engineering server. Engineering server, like any other Windows node, will have this system file configuration only in the ddna folder. ddna, if you go into an engineering node, this demo server is also an engineering server. So I'm showing here, this will have under DNA only the system file. What will be running there is your diagnostic may be running. You will be doing your diagnostics, no? That slot will be running. Your maintenance slot will be running. But there will not be any group file, BU group file or sys file here. Only this diagnostic, you can see here, diagnostics will be running. This is web diagnostics and this is your normal diagnostics through your window. This one, dia. Only these things will be running in your engineering server. There will not be any group file that is specific only to your backup node to understand where to push that package. Somebody has asked, does every subsystem require a separate BU? Yes, every subsystem, that is for every 50 nodes, we need a BU. So every subsystem require a separate BU. This separate BU doesn't mean that it has to be a dedicated workstation. Even the BU slot, which I told, it will be running in slot number 15. That if you're running it in any other workstation, that workstation will become a BU. So anytime if your BU backup node failed and to bring and set up a new backup server, it will take a time. If you feel that it will take time, so operator station also can become a BU by copying the BU folder into that and installing the BU applications. So if any node you have the BU applications ready, you can just copy the BU folder, it will become BU. Some question is there like how other servers will respond for particular address during download or upload. I'm not clear with the question. Can you please explain? You can unmute yourself and let me know that question. I'm not able to understand. One more question is there like if we change live values in FBCAD in test mode, will that be available back if we remove ACN or restart ACN? If reserve ACN is there, definitely it will be available. If it is a standalone ACN or both the things are restarted, if it is already backed up in BU, it will be there. Otherwise, it will not be available. The last value, whatever we simulated, no? If there is a at symbol and it is backed up in BU, it will be there. Otherwise, it won't be available. What if spare server is not available? Only one hard disk available. That's what I explained. If spare server is also not there and you already have backup, you can configure the functionality in operator station also. Since the license is already available, you can run the particular slot in other station, either your operator station or engineer station. So the particular station will have that functionality, either operator or whatever you configure, that will become available. Is there any limit in number of trend signals for trending? No, there is no limit. Uh, we have an Excel sheet for calculation on how many tags can be added to your info system. This calculation sheet is based on your hard disk availability. We will take into account the hard disk space available in our information server and the cycle time. At what interval your this is scanned. So all this we can take into account. We can calculate the sizing. If it goes beyond that, many signals cannot be accommodated. So this calculation will be explained in your info server session. How to calculate the number of signals and based on the storage space availability, like how long we can store. All those calculations will be explained. We have a defined working sheet for that. Can we add a local tags to trend? The tags which we locally generate in FBCAD. See, there is a Excel utility. I don't know like whether you are using in your plant or not. Through that, what happens is you can query from your repository. Whatever exists in your repository, only those signals can be added. If this signal exists in your repository, it will be shown in that Excel sheet. The query sheet will be shown in info session, through which it will show like all the list of available signals which can be added. If this also existing in your database, definitely you can add it to your info server. For replacing a new ACN, what is the procedure? What are the requirements and procedure? Uh, Only the memory card which is existing in your old ACN has to be taken out and put in your new ACN. That's all. There are no other procedures. You can bring the new ACN, old ACN card, take it out and put it in the new ACN and connect the networks as per network scheme. That's all. Because already all the files, everything is taken from your BU. You need not do anything. Only the card matters. Take out the card and put in new ACN and connect it in network. What if engineering server power fails or get corrupted? I hope you are maintaining the database backup. There is a utility called in there are different kinds of backup taken from your engineering database. One is your, see this latest AIDB OK backup. This copy exists in your BU also. So we can take this from your backup node and we can build the database in your new system. Whatever system you bring in as a new engineering server, no, we will be able to rebuild it. This backup is also available, and you can also take a backup using this utility ddna ea bin. There is a utility called dbgui database. This is user interface, database backup user interface. If you run this, see, this is an utility to take backup and keep. If you have not backed up your database, you can take a backup and keep. So this is exporting. It will export as a zip file. You want all or any new data. All means you can select all and give export. So you can copy this and keep in a hard disk. So in case your engineering server fails due to any corruption, it can be imported back. Through this also we can do, and through that AIDB backup which I showed, through that also we can do. There is a defined procedure available. Through that we can bring it up. Can we increase data storage for existing info server? We need to check the hardware configuration. If hardware the hard disk slots are available, we can put in few more hard disks. We can populate few more hard disks and RAID them so that we can increase the space. So the hardware data sheet is required to check whether it is possible or not. Yes, we can do it without losing existing data. Only thing we need to check if it is possible. If some signals local tags are not found in repository, means we cannot add them actually. It should be existing in the database. Then only we can add it. During plant running, another question, during plant running, unfortunately, if BU and DAS are powered off, then what will happen? Nothing will happen actually. In a running plant, BU outage will not cause any problem, any issue. So you will have enough time to bring them up. Once it is brought up, there will not be any problem. Even the outage of BU, because BU and EAS do not have any interference with running plant. Once your applications are running, they perform on their own. As I told, since there is no server architecture, it is all distributed. So operator station will have one-to-one connection only with ACN. So in a running plant, there will not be any effect. Only the signals which are cyclically returned to BU, that will get affected. They are returned at frequent intervals like 8 hours or so. The values of some signals which we configure during configuration are returned back to BU. So that will be affected. Apart from that, running plant will not have any implication. In which cases ACN changeover happens? This actually a document is available. You can approach and take from us. Like there are several scenarios defined on what all conditions ACN changeover happen. This you can take from us. There are few conditions which we define in our file also. ACN hardware and system file I was defining. There are a few conditions we define there also, like based on the number of faults, field bus fault, based on that, like if 3 or 4, like that we define. So based on that also it takes over. And apart from that, there are a few conditions. That document you can take from us. How can we see list of forced mode blocks of FBCAD all at once? This one actually, we have to, there is no application as such. We have to query from BU only. Any tool, okay, any tool is developed actually. We can check that and share it with you. A simple tool, it's nothing but the same command. What two commands we do know, like in BU we will check the current value and last value, and if there is a difference, then we will declare that it is changed. So this command is incorporated into a tool. A small testing tool is available. We can share it with you once it is tested here. Are there any more questions? Hope I have answered all the questions. If anything, ACN operating system is Linux based. Somebody has asked ACN operating system. It is Linux based, and all the Linux firmware files are available in BU only.
More questions, please, from participants. I think Archana madam, they are done with it. Lot of echoing. Please switch off your mobiles.
Madam, can I ask one question to Archana, madam?
Yes, sir. Tell me, sir.
Madam, how can we clone means the operating system like ghost image of the engineering server or something like that?
That is actually if we have a NAS, no, sir. We use the
Okay.
tool that system Symantec software we use, sir. It takes the entire image and push it to NAS. So whenever any failure happens, no, the entire image only will be available, and the incremental image is taken. It is through Symantec software, sir.
Okay, if the
But
NAS
I
is
don't
not
know.
configured, if the NAS is not configured in the station,
If you don't have a NAS and if you would, as I told, the backup of files can be taken. But if you need image only, means this software has to be purchased, sir. This Symantec recovery software. So it takes the complete image of all the systems that can be maintained in a disk, and this can be brought back in any new station in the same fashion. The image can be brought back in any news station. This is the software recommended by our collaborator also. We use semantic backup recovery software.
You have explained everything about the engineering servers. What about the backup nodes, madam? Backup nodes will be having any operating system?
Yes, sir. Backup node, from the initial thing only, I told that it is a Windows-based station only, sir. Backup node is a Windows-based station only. And even I have showed the files also, no, inside backup server, what all exist, about the
Yeah,
group
yeah.
file,
That
about the
thing,
system
that
file.
from engineering server you have shown, no? That
No,
that
no,
only will
it
be
is
there.
the backup node. That is the backup node. See, in the backup server, that BU folder will be existing. I was showing you the BU
Yeah.
folder only.
BU
This
folder
is
from the engineering server you have shown.
mine is a demo system, sir. So demo system has got all the features. So it is my engineering server, it is my operator station, it is my processor, everything is there. So I was opening from the same station, but in your plant, every functionality is different since it is real time.
Okay. If the engineering server fails, there will be no problem with the operation
No, sir,
activities,
no.
madam.
No, sir, no. There will not be any problem with your operation for your running plant.
If the engineering server fails, can we make the client also as an engineering server temporarily until unless this engineering server gets back?
We can do, sir. We can put the database there. As I told, like how to take backup of your database. We can
Yeah.
put that, and license is required, sir, for
Okay.
engineering server. If license is available, we can very well bring that into engineering server.
So until or unless engineering service is there, we can't download or
We cannot
down.
make changes to the existing logic. Otherwise, the
Okay.
existing one will keep on running.
Okay. Okay. Yeah. That if you take the copy of the license and put in the client server also, client also we can't do the
No,
changes.
sir, it will not work. No, no, it will not work, sir. It is always bound to particular station.
Hmm. Okay. But this ACN, what is the Linux OS that will be using, ma'am?
Uh, that I need to check, sir. I don't know the exact flavor. I can mail you, sir.
The communication will be from DB, from Windows to Linux automatical conversion from backup unit only.
Yes, sir. Yes, yes.
Okay, ma'am. Thank you.
Yeah, sir. Welcome.
Any more questions? Any more questions from participants? I think our participants are done with. And I thank Archana Madam for having taken this technical session so well and answered all the queries of our participants. And hope this is helpful to you, my dear participants. And I think we are overdue for the next session. I don't know what is your opinion. You can only take, I think so, only 5 minutes break and not more than that, because otherwise the other session will also prolong and our schedule will get affected. So what do you say? One each from both the customers can represent and say what do we do. 5 minutes should be sufficient for you. Kindly come up. Engineering using this tool, and the faculty for this session will be Mr. Kiran Kumar, and he's got a very vast experience in this generator controls group. Let me introduce him in a short introduction. He's done engineering for major Valmet projects like Naiveli RM 4 into 210 megawatt, Lalitpur 3 into 660 megawatt, Syntex Infra 2 into 150 megawatt, and then Nalco R&M 2 into 120 megawatt, Kottagudem 800 megawatt project also he has handled, and he has taken 7 copyrights for our office, that is to BHEL, in different topics in the area of steam controls. So we are proud to have him The session will start. I'll pass the host rights to Kiran. Please take over.
Not coming, now? No, sir. It's not coming. Hello? Can you hear me? No.
Yes.
Madam,
ಹೇಳಿ
ಅವ್ರದ್ದು
ಹೇಳಿ ಹೇಳಿ
ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ವಲ್ಲ ಅವ್ರ ಹತ್ರ ಕಿರಣ್ ಅವ್ರ ಪಿ ಸಿ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ. ಓಕೆ ವೇಟ್ ಸರ್ 2 minutes.
No, you adjust the speaker in his PC. Some system like that you put. In the top menu bar, there is one audio video option in which if you go, no, audio from a computer system like that, that option to be clicked, then he can also hear our voice and we can hear his voice.
It's coming.
Sir, can you hear me?
Okay, adjusted, Kiran.
Sir, are you hearing? Okay.
Yes, he could talk it and we could hear. I don't know whether he can hear it.
Madam?
Kiran, is it audible? Kiran, is it audible?
It is audible now, ma'am.
Okay, carry on. It's also audible to us. You can carry on the session.
Good morning, all. Today morning section is this DN Explorer and FPCAD. As this is a tool based, no PPT will be there. Just I will be explaining the tool to you and how to create the folders and all those things. This DN Explorer is used for creating loops, pictures, sequences. Everything can be created from here only. This is like all-in-one tool where you can create logics, pictures, and everything. To open this tool, it will be there on your desktop. Otherwise, you have to go to Start. In the Start, you can able to see this DN Explorer. Once you click on this server name will come for you. For you, generally AES will be there or VAS will be there. As this is a project server, here VAS 19 was there. Click on that, and this DN Explorer tool will be open for you. And this is the DN Explorer. Here you are able to see here process area hierarchy was there. In this only generally we will define the project name, where under the project name you are able to see the packages. These are all the ACNs in the project, and displays also separate folder will be there. Again, this DN Explorer, 4 types of hierarchies will be there. One is process area hierarchy, one is package hierarchy, where individual ACN what loops are there you can see here. Then is network list hierarchy. When you click on this, all the loops in the project will be available here. And one more is network hierarchy, where you can see address wise what signal is assigned in the network. Let me tell you by creating a sample process area hierarchy. For creating a sample process area hierarchy, right click on the go to the object. You can define a new process area. Example, I am defining sample project. I am defining a sample project here. This was added here. To view this one, you have to refresh this one. Refresh button was there in the DNA Explorer. You have to refresh this one. So this sample project is appearing here. In this, I'm creating one package. AP01 project package I'm creating. It is already there. I'm creating one more package. And under this one, this is the ACN name where we'll have all the logics and all those things. In this, if you see, we can create hardware and software, different folders. Example, I'm creating object hardware. Again, one more object software I'm creating. In this, all the loops will be there. Now, I will show you one example project where you can see. You see, I'm considering this Vijayawada example project. This is a project server where this Vijayawada is a project name. Under this, this almost 20 ACNs are there. In every ACN, a separate hardware folder is there and logic folder is there. Under hardware folder, separate AI, DI, DO folders are there. Where once you click on the AI folder, you are able to see all the loops of that AI folder. Again, for the DI, you are able to see all the loops of the DI folder. Similarly, for DO, again logic separate folders are there. This is how to create the folders for a particular. If you want to add a new folder in a sub area, simply go to the path where you want to add the folder. Example, logic, object, new process area. Suppose if you want to add here GSPC, simply add new process area, write GSPC over here. Once you refresh it, GSPC will be added here. And whatever logic you can make, this can be brought out here and it can be kept here. And in this DNA Explorer, there will be 3 workspaces: repository, default workspace, and library. Here, for our engineering, additional workspaces are there. Generally in the project, we have only repository, default workspace, and library. Library is the place generally we will store all the templates. Template thing I'll come to you later. What is template? And this repository workspace will keep all the project related files. For example, this AP01, this AA folder is having all the files in this one. In the repository, all the files will be there. Suppose you want to modify some file over here. What you can do is you can use these options. Move to data storage option will be there, where the total file will be moved to library or default workspace you can move. Otherwise, what you can do is you can keep the file here and you can use this copy to data storage. One option is there. There also you can copy that file to the default workspace so the original file will not get disturbed. And once you have moved, so example I'm moving this one. So I have moved this R1M8 channel 7 CJF01. I have moved into default workspace. So this file is appearing here. And this file, whatever modifications we want, we can do it here. And after that, we can move it back to repository so that 2 copies will be maintained to you. Like if you want to take some backup, you can move that file to default workspace and you can modify the logic in the repository and you can send that logic to the ACN. These are the different options here. This is the download option, this particular button. For downloading the logics, this button will be used. And one is this refresh button. If you have modified any logic or if you have brought any new logics, for able to see the logics here in the page, you have to refresh it once. For this, refresh button is provided. This is search button where you can search a particular tag. Example star. If you want to search a tag which is ending with which is having the name tag, if you do like this, and if you do search, all the tags related to that whatever tag names is having this tag, this will appear in the window, so you can directly open from here. Then if you want to export a particular package to the desktop, what you can do is you can right click on this export option. I'm exporting this AI folder only as the total folder will take so much time. I'm exporting this AI folder on the desktop. I've created AI folder of AP01. This time double clicking on this and save. This all the files have come here. This is like if you want to take a backup of a particular folder or a particular ACN, just simply click on the folder name, right click on the export and create a folder name and name a package on the desktop or whatever location you want. Just save it, all the folders will be exported. Suppose if you want to import the same files, whatever, suppose some backup you have received from somewhere or some backup you have taken long back, if you want to import these things, there one option is there like object import. I'm not importing this things, just I'm showing you because this will disturb the project thing. Click on the folder. If you want to import all the files, select all. Otherwise, click on the particular file and import the files. Just press open, it will import all the files into the folder. After that, you have to refresh the files. Then we have different options like if you right click on this, we have different options like properties, where you can see the properties of a particular loop, and you can edit without opening the loop. You can edit the all the properties from this using this properties tab. Otherwise, if you want to edit multiple things, what you can do is you can select 2-3 loops using control and select display properties in sheet. So it will open all the attributes of the, like if you want to modify the similar attributes, what you can do is you can select multiple loops, and similar loops can be selected and edit if you press edit all if you press. It will give you an option to edit the attributes of similar, like if you want to edit a similar attributes like alarm priority example, if you want to change it to 100 example, you can change it for all similar using this edit all. Once you have edited it, you can go to object, save, change it you can do, so it will be saved. It's like next is like download to option. These like important functions I'm telling you. Download to option. Again, you can do the change template. Suppose some template you have changed. If you want to change the template for a particular loop, you can do the change template. Like any custom block, if anything composite function block, anything new thing you are receiving, you will be using this update composite function blocks. And if you want to export only this particular loop, you can export it. And if you want to convert this into a PDF, simply right click it, export to PDF you do. This there is no space in this one. No? I'll try to export somewhere. This for exporting it to the PDF, what you have to do is, suppose if you want to export the total files in the folder into a PDF, just right click it, export to PDF option will come here. And once you press that one, all the files in the particular folder, it will be, for you it will appear as a PDF format for future reference. Otherwise, if you want to export a particular file into a PDF format, just right click on the particular file, do the export to PDF. So same thing will be converted into the PDF format. In this DNA Explorer, there will be different kind of loops like FBCAD loop, sequence CAD loop, and composite function block, and pictures. This all these logics will be there in the FBCAD format. One logic I will open to you. This is the FBCAD file where all the logics will be defined in this file. Suppose if you wanted to open a display, This is the picture designer where you can create all the displays for a particular project. Like similarly, sequence CAD will be there. One way to create a particular loop is go to create, click on the function block diagram, and you can create the loops. Pictures also you can create the same, sequence CAD, everything you can create the same using this create option. This is like starting from the scratch. Instead of starting from scratch, we'll have these templates in our library. Example, this test lib, if you see, these are the different templates available here. Templates is like a skeleton for a particular logic. Suppose if you take a, like if any plant, if you see, you will have digital inputs, digital outputs, analog inputs, analog outputs. For every particular address, like particular tag in the field, you will have a signal assigned in the DCS. To assign everything, every time we need not to start from the scratch for a particular signal. For that, what we will do is we'll have a template kind of thing where there is a basic skeleton where you can define the tag name, description, ranges for these things, and so it will be converted into a loop so that the total structure will remain same for the particular type of tag. Like digital means only one kind of template will be there. If you see here, bin, this b10 underscore bhl is the digital input. This is the template. This is the logic for a digital input. b10 underscore bhl. Similarly, for digital output also b01 underscore bhl will be there. Seven, can you mute your mic? Seven Babu, sir, can you mute your mic? Seven Babu, sir, can you mute your mic? Disturbance is coming. Online. Seven Babu, sir, can you mute your mic? This is the DO template. And types of templates are available here, like for RTD, particular template will be there. For thermocouple, a particular template will be there. For analog output, separate template will be there. If it is a tree transmitter selector, just connect the three inputs in the template. Output will be available you. For the tree transmitter selector also, separate template is available here. Again, for axial displacement, vibration, separate templates are available here. If there is a bidirectional drive, based on the release conditions and auto conditions, separate templates are available. Again, for solenoid valve also, separate templates are available. For motor also, separate templates are available. Instead of starting from the scratch, what we will do is we'll use these templates and start the project. Now, if you see any DCS signal, in the Valmet DNA, we'll have this address format. Like suppose example, if I am taking this as a network structure, this is example I am taking. This is a suite of 3 panel, CJJ3, CJJ4, CJJ53. In the first panel, I am having 4 racks. In the second panel, I am having 6 racks. In the third panel, I am having 6 racks. So this ACN is totally having 16 racks. To define an address for a particular rack, like every signal, every tag should have a unique address in the network. Like in this MBA8, as already hardware section is explained, here modules will be there. AA, DA, and all the modules will be there in this MBA8 things. Suppose and first MBA8 will have 0 to 7 address. Second MBA8 will have 7 to 8, 15 address. If you take this DEVO module, if you see here address formatting, -1 colon -1 colon -1 colon -0 is there. Means this format is like this is a 4-character address format where the first character denotes the FBC address, the second character denotes the rack address, third character denotes the module address, fourth character denotes the channel address. Example, if I take this particular network thing, the first rack in the structure will have the 0 address of the rack. Second one will have the first 1 address of the rack. Third physical rack will have the 2 address of the rack. Fourth physical rack will have the 3. It will start from 0, 1, 2, 3, so on it will continue. If it is a suite of 3 panel, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Suppose if you want to give a address for a rack to second module addressing also starts from 0 only. Like if you are having a 16 physical modules, you will be having a address like 0, 1, 2, 3 up to 15. Again, channel address also starts from 0. If you have physically 8 channels, means channel addressing will start from 0 to 7. The first channel will have the 0 address, the second channel will have the 1 address, the third channel will have the 2 address. Suppose if I want to give a address for a fourth module in a rack 2, the first one is the FPC address. This I will explain you later. So I want to give a R2M4, rack 2 module 4, channel 1 I want to give the address. I am giving the first bit as 1, means it is R2, physically it is 0, 1. Like second rack will have the 1 address. After that I am giving the address for R2M4. CJ3 R2M4 channel 1 I am giving the address. This as it is rack 2, which is in the first panel, I am giving the address as 1. The next for module 4. So physical module is this one is 4, means generally we'll start from R2M0, R2M1. So M4 means this 4 only is there here. Again I want to give the channel 1 address. This channel is 2. This is the addressing format. If you want to give a particular address for a R2M4 channel 1, what you have to do is this first character remains same. This is depending on the FBC. Second one, suppose rack 2 means address is 1. Then module location M4 means physical module location is 5. Then channel 1. This is how we have to give the address. Suppose it is a redundant thing. What you have to do for redundant address, you have to give 2, 2, 4, 1. This is for redundant addressing. And the first character, this is like suppose if ACN is in the same network, like if you see this all is in the same network only, so the first character remains 2. Suppose sometimes you will have a more than 16 racks you will have, otherwise ACN will be there in the control room, and sometimes what will happen is these racks will be located in some far area. At that time this will be extended through optical fiber from the ACN. At that time for these remote racks, the first character will be changed to 3. Instead of 2, first character will be changed to 3. This is for remote IO, or if the racks are more than 16, the first character will be changed to 3. Otherwise by default the addressing format is like 2 colon rack address, module address, and channel address. And this 2, depending on the remote IO, this 2 will be changed to 3. Otherwise this 2 will always remain constant. Now I will be creating one sample DI using the template. And first I will explain these basic things in a template. Once you open the template, you will be able to see if it is a input, hardware input, you will be able to see a buffer inside. Suppose if you want to create a new tag, suppose if you want to assign a new instrument in the field to a particular card in the DCS, first you have to find out what spare channel is free. Based on that, whatever addressing format I have told you, that addressing format you have to arrive. Once it is arrived, this template will have edit design members. If you go here, one tag name will be there. I'll go to the template. This edit one design members option is there. Just go there, click on this one and give the tag name. Suppose example I'm giving sample DI. Package name I'm defining it as suppose if you want to take it in this AP10 package, I'm giving it as AP10 package. Suppose if any alarms are available for the here, if you want to enable alarm here, alarm attribute is there. If you are enabling this one, alarm will come. Press OK. And if you see here, whatever B01 under beta underscore BHL was there, sample DI it was created. And whatever package name I have entered here, this has come here AP10 package name. And execution time of this particular loop also, by default it was 500 milliseconds. If you want to change here also, this you can change. Edit design members, if you go, execution time will be there. This suppose if I am defining it as 250, execution time will change. And this order is like giving the preference for a particular loop. Suppose you have 10 loops, you want one particular loop to be executed faster, like it should come as a preference. Then if you reduce the order number, the particular loop will execute faster. Suppose if 10 loops are there, 10 loops controller is giving the some operation at the same time. Suppose if you want a particular loop to be executed faster, to be executed first in a preference, then based on the order, this controller will select which loop. Suppose if you have execution times 250 milliseconds, 10 loops if you have, and particular one loop has to start first. Then based on this order, it will start. And if you want to edit the address here, go to edit values. One option is there. Once you press that one, click on the buffer, and this addressing will appear here. FBC slot is common, so this I'm changing it to R2 M4 2 4 1. So this addressing was changed. Suppose this is a redundant thing. In the decimal numbers, one attribute is there like to define a card type, it is a redundant or non-redundant. Here DI8 is there, change it to RDI8. So redundant buffer will appear to you. Again you have to enter the both the addresses. I am giving 2 2 4 1. So once you have entered the address in, just go to file. One check option is there. It will check for any errors in the particular loop. This Mahapatra sir has asked one question where the order number can be same or unique. This order number generally it will be same only, sir. Only sometimes if a particular loop has to be executed faster, then only we'll give that particular loop as 19 or 18 depending on the number. Otherwise generally order number will not have any effect. Generally 20 will be there because all the loops generally it will be executed. This requirement will come in a very particular loops like HTC and all those things, where a preference has to be given to a particular loop. Then we will reduce the order number. Otherwise for normal applications this order 20 is sufficient, where for all the loops order 20 only will be there. Only for particular loop where it has to be executed faster, like suppose similar command is coming from both the loops at the same time, and sometimes one loop has to be executed faster, that generally based on our uh, uh, practice we will decide this order numbers. Generally mostly for normal OLCS and CLCS normal applications, it will be mostly 20 order only. This is sufficient. This loop is created now. As you open from TrustLib, all these templates will be available in this TrustLib folder in the project. As I have opened from the TrustLib, this particular template what I have created, sample DI is created here. So suppose if I want to move this to the sample project folder, what I have created already. In the hardware, I am creating a DI folder again. For creating folder, already I have explained you. Go to object, new process area hierarchy, give a name. I am giving the DI name. This file I have created here. What you can do is right click on this folder, properties, edit it. So I am moving this file from here to that sample folder, what I have created, sample project, hardware DI folder. You can select from this option here. I'm pressing OK. Yes. So this file will disappear from here and it will come into that folder. Sample project AP01 hardware. You can just see this folder here. Suppose if you want to edit a particular attribute in the folder without opening the loops, simply right click it, properties, and all the attributes for the particular loop will be appearing here. Suppose if I want to disable the alarm without opening the folder for hardware files, this $of attribute, making it 0. Suppose if I want to change the alarm text, sample high, without opening the file, can be able to do it from outside using this properties attribute. Properties, and you have to go to this edit. Otherwise, the one more way is you have to open the file. Go to edit design members. And you are able to see whatever design members are available. Same thing you can see outside. Directly you can edit from outside. Otherwise, you have to open the loop, go to edit design members, and you are able to see all the attributes here. I'm changing it back to 1. This is one way. After that, you have to go to file, check. Yes, I'm pressing. It will ask like which storage. Suppose if you want to change it to default workspace, also you can change it from here. Okay. As we have created the loop, suppose if you want to download a newly created loop, one option is like click on the loop, press on the download here from the top. If you are downloading the loop for a first time, you have to use this add option. Then press OK. It will download the loop. I'm pressing OK. This download is happening in the background. Once it is finished, I will get back to you. And otherwise, I'm cancelling it. Once you press this download button, it will get downloaded. Otherwise, one more way of downloading is, I'll explain this one. Right click, download to option will be there. Once you click on that download option, you can do it from here. Once you have created the loop, you can download the loop from the top, or just right click on the folder, download to option you press. That loop will be downloaded into the controller. Suppose if there are any hardware changes in a particular tag for the same tag name, so suppose if you want to change the address, like suppose if the same tag name is having R2M4 channel 1 address as before, suppose if you want to shift it to R2M4 channel 3, what you have to do is, first if already loop is existing, you have to do this download. One delete option is there. You have to press download delete. So that loop will be deleted from the controller first. After that, you can do the address modifications and you can download. Suppose if you are not doing address modification and just changing the loop, and if you are downloading it directly, what will happen is with the particular address, already one loop is existing in the controller, and same thing you are changing the address and you are trying to download once again with a different tag name. What will happen is for the same tag name, both the addresses will be there in the controller side. So it will happen like no tag will communicate to the ACN. Like one fault error will come and none of the tags will communicate. So what you have to do is, if you are disturbing anything like changing the channel and all those things, first for the particular tag you have to do the download delete. For this you have to press this download and delete option. If you press OK, if you press, this tag will be deleted from the controller, not from the, suppose I am pressing here download delete. This I have changed the project server. That project server is little bit slow. Downloading is taking time. I have changed the project server. Suppose once your loop is created, if you want to add, just click on this button. Use this download option. Add. This server BU is not working. Error is coming. Otherwise, this loop, if you want to download, delete it again. Just click on this. Delete. Press OK. It will be deleted from the ACN. This maximum, we can create only 4 hierarchies for any particular project. Suppose if you take this project, example, this other 3 is the project name. In that, AP23 is the package name. Again, hardware folder we are creating. In that AI folder we are creating. So maximum 4 hierarchies we can define, like YADA3, AP23 in that hardware, in that AI. Suppose if you want to add one more hierarchy, here the hierarchy will be taken, but once you import and export the loop, only 4 level of hierarchies will be there. Like once you export the loop and import it again, what will happen is, suppose if I am creating one more AI underscore 1 here, here folder will be created. Suppose if you are trying to place some files in the 5th level of hierarchy, what will happen is once you are trying to export the files and import the files, all these files will be moved into the AI hierarchy, like one level before only it will move. Maximum this system will allow only 4 level of hierarchies in a particular file. These hierarchies, if you see, these things will be there in the loop. Because if you see here, this is the FBCAD loop where I have already explained you here. This is the tag name, this is the package name, execution order number. This is the buffer where the signal will acquire from the hardware module. And this is the project hierarchy, like YADA3, AP23, hardware, AI folder. If you see here in the loop, only 4 level of hierarchies are there. If you are trying to create one more level of hierarchy, that hierarchy will be created as a folder over there, but it will not come into the loop. Only 4 level of hierarchies only will come into the loop. So if you're trying to export this particular loop and import it again, if you're trying to export this particular loop and import it again, so what will happen is only this particular loop will be moved into the fourth level of hierarchy, even if you try to keep this in the fifth level of hierarchy, because as this loop allow only maximum 4 level of hierarchies. For hardware signal, we have basically 6 type of signals. One is digital input, digital output, and one is analog input, one is analog output. One is analog input, one is analog output, one is thermocouple input, one is RTD input. And these 6 type of signals, we have the templates for these things. If I will open this analog output, analog output, basically it is a analog module which is having 420 milliamps output or 020 milliamps output. This generally will give it to the control valves to control the this actuators, those actuators. This generally they will have the 420 milliamps, and we can define the range for here, like making like 420 corresponds to 0 to 100, or sometimes it may be 0 to 20 or 0 to 30 also. For defining this range, we have to go to edit design members. Here device tag minimum, device tag maximum was there, and unit also was there. So I suppose the range can be 0 to 200 MNWC, that will corresponds to 420 milliamps at the field. So this range we have to define here. This is analog output and thermocouple. This thermocouple module, this is input module where tag design members are defined like this. Thermocouple type, if it is a K type or T type or J type, we can define from here. By default, generally most of the times K type thermocouple will be there or T type thermocouple will be there. For this, if you want to change a particular thermocouple, suppose if you are creating a new thermocouple at the field, suppose it is a T type thermocouple, simply we have to go to the attribute, go to the design members, and type of thermocouple, one attribute is there, change from K to T, and range and all those things, by default it will come automatically. Otherwise you can define, suppose if you want to restrict the range to 0 to 600 also, you can restrict it. And for any particular loop, if you go to see any analog input, these are the alarms available here, like high, 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 low, low, low. These for all the analog inputs. Like if you see here, if you want to define a alarm, edit design members. Like if suppose if you want to define only high, high alarm for this, HH alarm in use on attribute is there. Just we have to make it 1. And this alarm priority will be there. Alarm priority generally it will be like 0 to 1000 will be there. Like 999 is the highest priority where we'll use it for SOE purpose. And the next one is the 900 alarm priority. I have laid it on a notepad. We have 6 type of priorities are there: 600, 900, 700, 500, 300, 100. These are the different types of alarm priorities. 999 we are using for the SOE purpose, highest priority. Then 900 we use it for the high priority alarms. The next priority alarm will use it 700. Next priority we use it 500. Next priority alarms use it 300, 100. 100 is the lowest priority. 900 is the highest priority for alarms. For 999 we will use it for SOE purpose. If you see here, high is the highest level of alarm on the higher side. So it was defined as 900. So high alarm priority is defined as 700. Again on the lower side, L is the least priority than LL. So it was defined as 700. And LL is defined as 900. Suppose if you want to enable only high alarm for a particular tag, what you have to do is you have to go to edit design members. HH alarm in use we have to enable. Then if you need alarm at suppose this is a 0 to 500 range, if you need alarm at 395, what you can do is suppose if you need alarm at 400, simply change it to 400. So alarm will come at 400. So if you see here, this particular attribute was changed to 400. Once if you save it, it will come. Alarm will come. And we have different type of other templates also, like MTR for motor L2D and H2D. For bidirectional drive we have MCA template. For solenoid we have MGV template. Example, if you see, this is a sample motor template where it is having two inputs from the field, on feedback and off feedback, and on start command and stop command was there. And these are all the drive related. This is the main block which will run the drive. Like if you want to turn off, this is the block which will communicate to the HMI. This is a sample LTUD template. Similarly, we will have this for bidirectional drive. We have this MCA template. It will be available in TrustLib folder. MCA, MGV, MTRS folders are there. From the here you can start from the scratch. Like if you want to define a new bidirectional drive, what you can do is you can open the template, go to design member, give the name. Like MCA template was there, MGV template was there, MTR template was there. Otherwise, what you can do is you can suppose if you want to start from the existing one already. Suppose existing loop is there with you already. If you want to start from that example, suppose if I have this already, this pilot valve already one I have. Suppose if I want to change it, that already existing one, suppose man51A001, one particular drive is there. Suppose sometimes we have a requirement like change it the same thing, like all the attributes will be similar only. Just you have to change the address and make a separate drive. Like suppose similar drive is available at the field. What you can use, one copier tool option was there. Go to design, copier tool, and whatever attributes you want to change, you can enter it here. Suppose I want to change it from man51 to man61. Again LPBP SV -12 LPBP SV-2. Whatever attributes you want to change in the particular thing, just press OK. If you see here, I want to create man61A001. Simply I have selected man51 character, only that characters have changed because A001 is constant, and LPVP SV1 to LPVP SV2 have changed. But once we have opened this one, this address will be same as man51 only. This address you have to correct according to your requirement. Then you have to download the loop. Otherwise, what will happen is the same addresses will be there for man51 and 61 also, and that ACN will take the downloading, but later both the tags will not work, both the outputs will not work. So before doing these things, what you have to do is you have to download delete. Like if you are modifying the existing one, you have to download delete. If it is a new one, it will throw an error like address is clashing with the other one. So new address you have to give it here and you have to download it. This is the copier tool functionality. I will repeat once again. If you want to create a new tag for a similar functionality, like only some characters are changing. Suppose man 50, in this case, man 51 to man 61 is getting changed. For this thing, what you have to do is go to design, copier tool, right from man 51 to man 61, press OK. Similar tag will be created. So that tag you can download instead of creating from the scratch.
Sir, I will take 2 photos. Okay. This customer is asking.
And we have templates for transparency selection. Similarly, templates for transparency selection we have. This is regarding the main functionalities in the DNA Explorer. Now I will go to the FBCAD. I'll start with FBCAD basics. For creating FBCAD from the start, what we have to go to, we have to go to this create function block diagram. Once you click on this, it will give a new FBCAD diagram. In this, where we can draw the logics. If you see here, this is the FBCAD diagram where we have taken from the scratch. This will not have any design members. If you see here, edit design members only, nothing will be there. Tag code, nothing will be there. So if you want to edit here, go to edit values, click on this package. Again here, everything you have to define. Design members are not there for this particular loop. You have to define here, like I'm leaving sample.f. Again, this thing will be available here, bottom. Edit values, sample. Like sample, you have to write at the bottom and the top also. Again, I'm changing this package to AP23. Execution time as 500 milliseconds. I'm doing a file check. So I have started from the scratch. This type of loops will go into the not categorized folder. Means I have not assigned any folder for this. It will go into the not categorized folder. This loop will be appearing in this sample folder. Suppose I start creating this project hierarchy, like object, new process area, sample. I'm moving from the not categorized to the sample folder or whatever folder we want. I have created a sample folder. I'm moving it to the sample folder. This loop is already opened. I'm closing it. If you see, it has gone to the sample folder. Now I'll explain one project hierarchy. Now I'm taking this Yadadri project. In this Yadadri AP23 is the package name. In this we have different type of hardware, analog input, where all the analog inputs are stored here, all the analog hardware tags like AO, DI, DO, RTD and thermocouple. These will be the different types of inputs available with us. And for this logics we are creating in the separate folders, like suppose LP bypass protection is there. We have created a folder under the package name software LP bypass protection, where if condenser pressure protection is there, separate folder is there in that loops. As maximum 4 level of hierarchies are allowed. AP23 software LP bypass protection condenser pressure. In this condenser protection logic we are making. Again for alarm separate folder, for GSPC separate folder, for HPC logic separate folder, for LOPS separate folder. These are the different types of folders based on the requirements we are creating. And coming to the drives, every drive will have one main loop, one child loop. If any additional logic is there, we are giving the additional logic in that additional loop. Like AP example, if you take Max05 AP001, the child loop will have this auto on, auto off logics, and this underscore logic will have this any additional logic required. It will be stored in this one. And I'm opening this example. I'm opening this man. Seal stream drain valve I'm opening. This is a bidirectional drive. Where you have this type of inputs like open feedback, close feedback, torque switch open, torque switch close, and MCC disturbance. Depending on the switchgear functionality, different types of inputs will be there. Sometimes it will be 3, sometimes it will be 4. Sometimes torque open will be there, torque close will, torque open, torque close will not be there. It will be combined in the MCC disturbance itself. And open close generally by default it will be there. And we'll have this open and close commands. Sometimes for bidirectional drives we will have an additional stop command also in some of the MCCs. And bidirectional drives generally will be 2 types of valves. One is inching valve and one is non-inching valve. If you want to convert from inching valve to non-inching valve, in edit design members, one attribute is there like actuator type, simply on-off valve or inching type valve. If you want to convert it to an inching valve, simply we have to change it from 0 to 1 attribute. I'm just changing it. I'll revert it back. So this will be changed into an inching valve. If you want to revert it back, go to design members, actuator type, change it to 0. Like here, if you see, everything is defined here. Actuator type 0 is for non-inching, 1 is for inching. Suppose if any position feedback is available here, if position feedback is internal, then 0. If it is an external feedback, you have to connect it as 1. And depending on the redundancy, like suppose some signal is redundant or non-redundant, everything is available here. RDA8. Suppose this is this type of input is not. Suppose this RDA8 is there. Suppose if I want to make it as non-redundant, simply remove that R. Write DA8 only. It will be changed into a non-redundant buffer. Similarly for outputs, all the attributes are available in the design members. Similarly, it will be for SOB and this one also. For MTR also similar it will be there. This is regarding DN Explorer basic functionalities. And regarding FBCAD, it will be explained in detail in the next coming section. Shall we continue with the doubts, if anything is there? Or anything to explain in detail can be asked. Someone, Mahapatra sir is asking, he has created a local tag and want to assign a alarm to that. How can we do that? This will be covered in the FBCAD section, but I will explain it to you in detail. No itself. So suppose if you have defined a direct access port like this, if you want to define an alarm for this one, what you have to do is you have to add here. If you go to modules, we will have 3 different type of modules: position, operation, and event. You have to add all the 3 modules for a particular type. Suppose you are adding the D tag binary. For this one, bin attribute will be there. You have to select all the 3, and you have to give the same tag name as this. MAW10EZ001. Like wherever tag code is there, this tag code you have to write it everywhere. Next is I'm taking operation module. Similarly, same thing you have to write. Wherever tag code is there, you have to write the tag name. Next is the event module. And these three blocks has to be there when you are creating a new alarm. This description will be there in the first block. What will happen is, suppose if you are adding this alarm bell kind of symbol is there, this will generate the alarm, but description will come from the first block. Suppose if you are defining only simple this alarm block, and if you are expecting an alarm, alarm will come, but if you can't see like what is the tag name and description in the alarm browser. For that to appear, what should be there? This operation module should be there. Position module should be there. Then only you can be able to see the description in the alarm page. I'll just show you. I'm going to edit values. Clicking on this one. Here, if you see, alarm message text was there. I'm writing alarm high. And alarm is already enabled. And the priority is what I have told has to be defined here. Alarm priority, I'm giving it as 900. So you can save this one. The similar thing is visible here on the top. This is the tag name. Control to identify everything is called come by default. And that alarm text you are writing here. Priority is defined as 900 for this one already. This is how to generate a new like if you want to define an alarm for this one, you have to create like this. Someone Santosh is asking like what is the operability of the tag in the position module. This is for suppose if you are writing the operability of tag is 1. Actually, these three blocks are for common purpose. Like you can use it for switching on and off. Like any HMI push buttons are there. You can use it for on and off for a particular button. Suppose if you want to, when you are clicking on the button, it will open a pop-up. If you don't want to open a pop-up, what you can do is simply operability of the tag you make it 0, so that pop-up will not open. Means that is not for operation. If you want to make a particular tag as operation, like suppose when you are making this operability as a 1 and you are using a button in the HMI page, when you click on the button, confirm and not confirm option will come. When you click on that, so that value will come inside. When you are keeping it as not operable, means once you click on the HMI page also, that option will not appear for you. It will show as an error as like this tag is not operable, like that error will show. So if you want to make a particular tag as operable, which is communicating from HMI, you have to define the operability of tag as 1. Otherwise, for normal tags like just for communicate, like only for signal exchange inside the loops, this operability of the tag is not required. Simply we can make it 0. It is only used for communication from the HMI side. And whether talk switches are required for all the drives, one question was asked by Ravikumar sir. This is like sometimes in the MCC, these talk switches will be combined in the MCC distributor itself. This talk switch open, talk switch close will be combined itself with MCC distributor. It will come as one input from the MCC. So it is depending on the customer and process requirement whether this talk switch is required or not required. Generally, most of the times this talk switches will not be there in some projects. Some projects this talk switches will be there. This is depending on the field requirement only. Sometimes what will happen is from the field itself, when it will be combined with MCC disturbance, actuated disturbance, it will come along with that only.
questions I think I have shown in chat.
That's it. How to assign faults in the watchdog? One question was asked. This generally here errors will be like 0 to 7. Some error codes are there. In the next section, we'll share it to you. Based on the code, that error will generate. Suppose this nothing is connected of any signal is gone out of range. One type of error will come. Like if any source like different sources connected to the signal, then some other error will come. Based on all this, suppose some input is not communicating from long back. Like suppose it is not connected at all analog input. Like some raw junk value was there, some old value was stored like that. Some old some other default fault bits will be there. Based on that fault bit will come. These things like watchdog will come based on the this fault bits what are appearing in the particular line. Like the example I will show you. Like based on the fault bit available at this particular attribute from the signal hardware, this watchdogs will be generated. Suppose if MB8 bottom connector is removed, one external fault error will come here for DI. That will propagate there and that will generate a watchdog for you. This is based on this available. This is based on the faults generated at the inputs. Or sometimes the communication will not happen and old signal will be value will be froze along with a fault bit. That will propagate there and that will create a watchdog. These are system generated and watchdogs will be assigned based on these faults which are generated. This Shravana Babu sir asked why we are connecting CB to AM2 block in AVO template. So this module, once we are sending the value, that checkback also module will send it back. As for AVO, we are sending it to the field. Just we are taking it from the module to the logic again, whether that value is coming into the field or not. This is just for ensuring checkback is signal AVO module is giving the value to the field or not. That is why checkback is connected. If you see here in a bidirectional drive, once the command is issued, it will go open from this field, it will go to the module. Again checkback will come from the to the drive again, and we are ensuring like this command has gone to the field, and again one more check back, we are taking it to the buffer, that is MCA template like command I have issued, and this then the time will start. So it will wait for that much time. And this coming to E1 to E5 in a motor or any drive, these are like these things should not be there to start a drive. These are like conditions which will inhibit to stop the drive. If you see here, MCC disturbance is connected E1. If you see here E1, MCC disturbance is connected. Suppose if you want to start a drive, suppose E1 1 is coming, this you can't allow you, it will not allow you to stop the drive. Based on this critical conditions, we will use this E1 to E5. Sometimes we'll use only E1. Sometimes depending on the MCC available at the field, we'll use E2, E3 also. This is for this E1 to E5. Any other questions? In the afternoon section, in detail regarding this FBCAT blocks, how to draw the logic, all these things will be explained to you in detail regarding FBCAT. Like regarding all the blocks will be explained to you.
Madam, Padma madam. Hello. Padma madam. Sir, finished.
Any other queries in the DNA Explorer like functionality?
Okay. Thank you, sir. First of all, I will thank our faculty, Mr. Kiran
So,
Kumar sir.
one question is,
Okay.
Srinivas sir has asked, why do we get error codes 32, 64, 128 FBCAD? What's the significance of this error? Sir, these are generated based on the faults available in the particular buffer. Suppose 128 is there, it is like that value is simulated. These things, if you see, once you are simulating the value, just click on the signal, go to edit values and click on the signal. There you will be able to see like 7 different types of bits, 0 to 7, where 7 is simulation and 2 power 7 will generate this 128. Means 128 is like that particular signal is simulated. And suppose if any external fault is there in the signal, or suppose if the signal has gone out of range, there are different codes are there for different types of faults. Like afternoon, this it will be explained in detail to you.
Okay, sir. First of all, I thank our faculty, Kiran Kumar sir, for sparing his valuable time and accepted our invitation for taking this session on Valmet DNA. Thank you very much, sir, Kiran sir. And also, I will thank all the participants for actively participated in this session. And thank you very much. And next session will start by 3 o'clock, sir.
3
Now
o'clock.
it is break for lunch. Thank you very much.
We break for lunch now and
Thank you
meet
all.
at 3. Same session will continue at 3.